Staying on the geometry side, we are going to work with special right triangles. So when we talk about special right triangles, right, we just saw Pythagorean theorem. Pythagoras said, hey, right triangles are going to work in this. That A, B, and C, where C is the hypotenuse, is going to work in this form, that A squared plus B squared equals C squared. That's in every single triangle, no matter what the angles. But there are certain special triangles that have some interesting 30, 60, 90 triangles. So a 30, 60, 90, that leg is going to have a relationship with the hypotenuse. So the hypotenuse is going to be 2 times the smaller leg, and the side opposite the 60, the long leg as they call, is going to be x rad 3, and we're going to use that. And if we did Pythagoras theorem with that, we'd still end up that x rad 3 squared plus x squared is going to be equal to 2x quantity squared. So that's the 30, 60, 90. 30, 60, 90 triangles. All 30, 60, 90 triangles will have those characteristics. And then the other one is a 45, 45, 90 triangle, where the legs are going to be the same because it's an isosceles triangle, and the hypotenuse is going to be rad x rad 2. So we're going to take that and we're going to use that to our advantage. So A is the short side. So if the short side equals 5, we know that the hypotenuse is going to be 2 times that, or 10. And we know that the long leg is going to be 5 rad 3 because it's going to fit in that that little thing, that if this is x, this is going to be 2x, and this is going to be x rad 3. So we're going to just substitute those values in for x to get our solutions. Pretty easy, really nice, fun, and we just have to locate the small leg. So A, so this time we see that B is equal to 6 rad 3. Well, remember that that represents x rad 3, that the coefficient of rad 3 will be my short side, and that equals x. So x is 6 in this case, and that's going to be 2x, so that's going to be 2 times 6, or 12. So A is going to be 6, C is going to be 12. We like that very much. All right, 30, so C is 20, so this is equal to 2x. So if we solve for x, we get A is going to be 10, and then B is going to be 10 rad 3. So A is equal to 10, B is equal to 10 rad 3, and those are still relatively simple. Yes. All right, here we go. I like this. This gets fun. So if we have 2x and x is rad 6, then that becomes 2 rad 6. Outside, inside cannot combine. You can't combine the outside. That does not become rad 12 or 12. It becomes C is equal to 2 rad 6. And B is going to be x rad 3. So x is rad 6 times rad 3. So this time it does, because they're both inside the house. So we can multiply those two. Now we need to simplify that, because we can break that down to rad 9 rad 2. And rad 9 is a perfect square. So we get 3 rad 2 for B. B is going to equal 3 rad 2. Like that problem a lot. That is, that's going to be one of the problems that you'll probably see. And that's a fun one. All right, now we're dealing with the 45, 45, 90. With that, that's going to be x, x, x rad 2. So if D is 7, so if x is 7, E is also going to be 7, and F is going to be 7 rad 2. That's really easy. E is 3 rad 2. So 3 rad 2, so D is going to be the same leg, so that's going to be 3 rad 2, and F is going to be x rad 2, so 3 rad 2 times rad 2 gives me 3 times 2, or 6. So f is going to equal 6. That's a good one. Got to know that you can multiply those radicals. And f is 5 rad 3. Ooh, that's good. So we could write it in this manner. And now let's solve for x by dividing by rad 2. Divide by rad 2. Now, a lot of students would leave it like this, but we can't have a rad in the denom. So how do we rationalize that radical? What's going to get rid of a rad 2? If I multiply it by another rad 2. And that gives me 2. And that gives me 5 rad 6. That can't be simplified, so this is going to be my x value. So d and e are going to be the same. So that's going to equal 5 halves rad 6 or 5 rad 6 over 2. Either of those would be acceptable. That's a good one, like that. Hopefully you got that one right. Find 2x. Okay, so let's divide by rad 7. X equals 6. These will cancel. And 2x is going to equal 12. That's kind of easy. Let's divide by rad 13. We get w equals 5. And w squared would equal 5 squared or 25. Ooh, I like that. This is good. Divide by rad 3 now. Y equals rad 6 over rad 3, which we can write under the same radical. And that can be simplified to rad 2. That can't be simplified more. So y equals rad 2. And if we want 2y equals 2 times rad 2. So 2y equals 2 rad 2. All right. Good. Another good content. All these important things that you should know from pre-algebra, algebra 1, and geometry. And a little smattering of algebra 2 concepts.